Have you ever opened up a software project and found something more? Not just a bunch of files and folders, but a system that's literally governed by unchangeable laws. Like it has its own constitution. Well, that is exactly the wild idea we're diving into today. And this is the very first thing you read. I mean, wow. That's not a suggestion, right? That's a declaration. It immediately throws you into this really radical idea about what truth even means inside a computer system. So here's the bottom line. Forget what the documentation says. Forget the helpful comments, the pretty diagrams, even what the files are called. We are about to step into a world where the only thing that matters, the only truth, is what the code actually does when it runs. Okay, so how does this actually work? Well, the whole system is built on what it calls a first principle. You can think of it as the ultimate tiebreaker. It's this one single rule that's designed to resolve any conflict, any confusion, and give you an absolute source of truth. And this just lays it out perfectly. On the left, you've got the winner, the undisputed champion, the executable deterministic replay. That's the ability to run the code and get the exact same result, bit for bit, every single time. And on the right, literally everything else. All the stuff we humans write to explain things. Prose, diagrams, comments, it's all secondary. If there's a disagreement, the running code wins. No contest, every single time. So what exactly is this law? What is this one sovereign rule that the entire philosophy is built on? Let's break it down. It's called typed deterministic replay. Now, that sounds like a mouthful, I know, but the core idea is actually pretty simple. Imagine you're baking a cake. If you use the exact same ingredients in the exact same amounts and follow the exact same steps, you should get the same cake, right? This is like that, but on a cosmic level of precision. The same inputs must produce the exact same bit-for-bit output every single time. There is absolutely zero room for chance. You can imagine this has some pretty huge consequences for how you'd actually write code. Developers in a system like this have a really clear mandate. You have to optimize for things that guarantee that perfect replayability, things like bitwise purity. On the flip side, you're basically forbidden from optimizing for things that just make it look nice for humans, you know? No prettier narratives or handy metaphors if they obscure what's really happening under the hood. So to pull this off, the system has to be incredibly strict. I mean, it just flat out rejects a ton of things we take for granted in everyday coding. There can't be any randomness, no hidden state that could change on you unexpectedly. The code can't care what time it is or what order processes are running in. It can't even depend on the specific machine it's on. Everything, and I mean everything, has to be self-contained and perfectly predictable. All right, so how on earth do you build something like this? Well, you can think of it as being structured in layers, kind of like an onion. We're going to start at the very center, at the core truth, and peel our way outwards to the crust, the part that we humans actually see and interact with. Right at the core, you have the runtime. This is it, the absolute canonical truth of what is happening step by step. Now, moving one layer out, you hit incidence. This is where structure starts to form. It takes all the raw events from the runtime and legally assembles them into something meaningful. Next up is the witness layer. This layer looks at that structure and gives it meaning, kind of like translating raw data into something symbolic, like Braille. And finally, on the very outside, you have projection. This is what we see, the UI on the screen, a JSON file, whatever. And the crucial part? Each layer is verifiably built on the one inside it. It's a chain of truth. But wait a minute, how do you connect these layers? How does the system make sure that the incidence layer is actually a truthful representation of the runtime? How does that chain of truth actually stay linked? The answer is this really clever mechanism called the step digest. Think of it this way. For every single tiny step the runtime takes, it creates a unique deterministic fingerprint, a digest. This little digest is like a seed or maybe even a strand of DNA. It gives the next layer out all the information it needs to perfectly and predictably build its own structure, based entirely on that one single event from the core. Okay, so this system has a really fascinating way of proving that it's actually correct. It doesn't just run. It produces different kinds of artifacts, what it calls surfaces. And each one has a very specific, very defined relationship to that core truth we've been talking about. First up, you've got the canonical artifacts. This is the raw stuff, the direct, unfiltered output of the runtime law. It's the truth, plain and simple. Next, there are golden artifacts. Think of these as the answer key. They're fixed, pre-approved examples. So when the system runs, it can compare its new canonical output against these golden files to make sure nothing has gone off the rails, that it's still following the law perfectly. And then there's a third type, negative artifacts. Now these are interesting. They're also lawful outputs, but their job is to prove that the system correctly rejects bad input. It's not enough for it to work right, it has to fail right too, in a predictable, lawful way. This table just pulls it all together. Look at how few things actually have canonical authority. Only the raw bytes and the runtime's event stream. That's it. That's the absolute truth. As you move down the list, the authority gets weaker. A witness has meaning, sure. A matrix is just for moving data around. And look at the bottom. A projection, like a UI, has zero authority. None. It's a crystal clear hierarchy, so you can always trace everything back to the source. Okay, so after all this deep theoretical stuff, you might be asking, why? Why on earth go to all this trouble? Why build a system that's so rigid? Let's talk about the payoff. And here it is. That user interface you're looking at on a screen, it has zero authority. It's just a projection. It's like the image on a movie screen. It's a witness to the truth, but it's not the truth itself. The actual film, the runtime, that's what's real. I mean, think about how many times you've used an app where the UI is all buggy and out of sync with what's really going on in the background. With a system like this, that literally can't happen. And that brings us right back to this core idea, this mantra. It really is the whole philosophy in a nutshell. The typed deterministic replay is sovereign. It's the king. Everything else, documentation, UIs, you name it, is just a witness or a derivative. It all serves the king. So the ultimate goal, the why behind all this, is to create a system that you can absolutely 100% trust. Because you can replay its entire history and verify it at the bit level. There's no room for drift, where the code slowly changes and no longer matches the documentation. In this world, the system does what the law says it does, and the law is what the system does. They are one and the same. And so that leaves us with a pretty big question to think about, right? I mean, we live in an age of unreliable data, of lying software, of systems that just don't do what we expect them to. So could this be it? Could this kind of constitutional, law-based approach be the future for building machines that we can finally truly trust?